All right, today is day 4 of the Taylor series, and today we're going to focus on actually finding the sum of a Taylor series. Now, back when we did the series chapter, there were 2 kinds of series that we were able to find the sum for. Do you happen to remember what they were?
P.
Not the P. The P is one of the... Geometric was one? Telescoping was the other one, okay? Now, if you have a Taylor series built off of a specific function, you can also find the sum of that series. And that's what we're going to learn how to do today. Now, you need to have out your flip book on that page that we just glued in, the one that says manipulation of series. What we are doing today in the beginning of this lesson is looking at these series that are here and matching them to one of the series on your paper. So, and this is how we find the sum. So, on the first one, we have this series right here, 1 plus 3 over 1 factorial, 9 over 2 factorial, blah, blah, blah. You need to really look at the nth term, the 3 over n to the n factorial. Which of the ones on that pink paper does this match? It matches the e to the x. It matches the e to the x, which happens to be, let me get it so I can copy it down exactly, because I don't have it exactly memorized. 1 plus x over 1 factorial plus x squared over 2 factorial plus x to the third over 3 factorial, dot, 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 and then x to the n over n factorial. Okay, yes, that matches e to the x. So this series right here, which is all pretty much numbers, the n just means I'm going out a million terms or something, matches this one term for term. But if we look specifically at the last term, what is x? 3. X is 3. Do you see that? Between this one that's highlighted and this one that's highlighted, this one over here has an x value of 3. So that means if I took the one on the right and I changed all the x's to 3's, I would get this one, wouldn't I? So the right side matches this. What would the left side say? E to the... What is x? What did I just tell you x was? 3. E to the third. So that happens to be the sum. The sum is e to the third power, which is approximately 20. Yes?
It's not really a smart question, but like, say it matches e to x, right?
Yes.
Why?
Okay. This series right here is exactly the same as this series right there, except all the x's have been changed to 3's.
So e to the x, that's a series for it?
This is a series on your pink sheet of paper. Yes. This is the series for e to the x.
It makes sense now.
Now, okay, this is important, folks. Do you understand how I got e to the third for the answer? This whole series over here that was written down, if I added up all those terms in the calculator, I would get e to the third. Yes?
How did you figure out x?
Okay, I looked at the last term. I noticed it was something to the n over n factorial. If you look on the pink sheet of paper, I know it's kind of dark. Give it a second. The only one that looks like that is this third one down. It says x to the n over n factorial on the end. And that's how I knew it was e to the x. Okay? All right. So let's do the next one.
That's it?
Yeah, that's all we do. We're done. That's the sum. That whole series, if I had the ability to add up a million terms, would add up to be e to the third, whatever decimal it is, and it's around 20. It would add up to be around 20. Okay, take a look at the next one. What series does this term look like? Looks like sine. Okay, this one matches sine of x, which happens to be x minus x to the third over 3 factorial plus x to the fifth over 5 factorial, dot, 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 and then it is negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Now, here's the generic. here's my specific. What is x? Everything matches between the two of those, except for the x. X is 2. Do you see that x is 2? X is 2 right here. Okay? So, this series that I wrote down as my problem is the sine series, except for all the x's have been changed to 2's. So that means that the sum is, what do you think? Sine of 2. Because if I put, over on the right, if I put sine of 2 equals 2 minus 2 to the third over 3 factorial minus plus 2 to the fifth over 5 factorial, this is what I'm getting right here.
So are we just going to look at it and know what it is?
Yes. Now, the next question which you're asking is, do I need to memorize this entire sheet of paper? Okay? The answer is no. You could, by brute force, get every one of these by doing the derivative, the second derivative, third derivative, fourth derivative, blah, 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 plugging in all the numbers and writing it out. You could do that. But the three that are used most common are sine, cosine, and e. Now, all you need to remember is that e is every term. 1x, x squared, x third, x fourth, x fifth, and so on. Sine and cosine, sine is the odds, cosine is the evens. And if you remember that, you can just quickly write it down instead of having to do all the derivatives and then plug them all in and then write it that way. Okay? So if you can get those three, you're good. The fourth one is what we did yesterday. The fourth is the geometric. Okay? All right, let's take the next one. Turn that light off. Find the sum of this one. Okay, this one's a little trickier. It doesn't really match any of the ones on the paper because of the way they wrote it. I'm going to change that last term just a little bit. I'm going to write it like this. I'm going to pull out the negative. Okay? This is the same as that, because that negative is really an alternator. Take a look at what's on your manipulation list and tell me which one this matches. Right. This one matches 1 over 1 plus x, which is 1 minus x plus x squared minus x to the third plus dot, 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 plus exactly what I have here. Okay, see how they line up? What is x? What is x? Well, it's kind of hard to tell within the series, but it's pretty simple right here. Here's the x to the n. Here's the 2/3 to the n. So x equals 2/3. Are you with me? Okay, now all we do is we plug 2/3 into the equation 1 over 1 plus 2/3, and we clean it up. What is 1 plus 2/3? 5/3, and if you flip that up, you're going to get the sum of 3/5. Now, Destiny, what did you see?
That's 1 over a plus r.
It's 1 over a, well, it's a minus r, but it's minus a negative.
Yeah.
You were exactly right. This right here, another way to look at it, that's a geometric series, with r being negative 2/3. Because every time to get from one term to the next, I'm multiplying by negative 2/3. And you can use that geometric series formula to get the sum also. But this is quicker, I think, and it matches the other ones. So it goes along the same way. All right? Questions? All right. The next problem, I honestly, until 2 days ago, had never seen this problem ever. But I think what's going on here is that this is showing up on AP, and so my friend who has written this worksheet is come up with this problem. Let me show you how this works. So, we have a power series that converges if x is negative 8, and it diverges if x is 6. Tell whether the following statements must be true, cannot be true, or they might be true. So let me show you how this works. We're thinking and we're talking about R's and intervals of convergence. So what I want you to do is right here draw that rather long number line. Okay? What is C for that power series? What is C? Not 3. -3. So in the middle of your number line, put a -3 for me. It definitely converges at C. Okay? You look at what's in the parentheses with X. It's X minus C, remember? Okay. This tells me it converges all the way out to -8. So here's -8, and it converges to there. So I'm going to put a bracket, because whenever something converges, we write a bracket, right? Okay? Now, based on that information, what does R have to be? At least how long? How long is that R right there? It's 5 units long, right? So if it's 5 units this way, it must go at least 5 units the other way, right? Where would I be at 5 units the other way? At 2. Okay, so for sure, it converges in there. For sure. Now, it also says that it diverges once I get to 6. So if I keep going out this way to 6, I'm all of a sudden at a diverging point. So I'm putting a parenthesis there. How far the other way must I go and be guaranteed that it's going to diverge? I have to go 4 units this way, which would be where? -12. And that's definitely going to converge.
So we went 4
I mean,
units
diverge.
from
I'm sorry?
We went 4 units from -8.
No. Yes, 4 units from -8. Because from 2 to 6 is 4 units, so I have to go 4 units the other way. Okay? Now, I know it converges to -8. But I know that it switches to diverging by -12. Somewhere in the middle is where it actually officially stops diverging. This one could actually go all the way to -9 on the diverging. I'm saying it backwards. This one could go actually all the way to -9 on the converging. It could converge all the way out to -11 and then all of a sudden start diverging at -12. I don't know for sure. So the blue part is definitely converging. When I get to the red parentheses, it's definitely diverging, but in between the two, I don't know what it's doing. Okay? So now we can answer the questions about might be true, must be true, and cannot be true. Look at the first one. The power series converges if x equals -10. Must be true, might be true, or cannot be true. Where's -10? It's right here. Do I know what's happening right there? No, that's no man's land. I don't know. So that might be true. And the reason being, we do not know convergence or divergence between -8 and -12. I don't know. Now we're not going to write reasons on all of them, just on the first one, and any of the others that are kind of unusual. Okay? Letter B. The power series converges at 1. Definitely, maybe, or no? Definitely. Why? Because it's in the blue section, right? So this must be true. Because R is 5 or more. R must be at least 5, right? R goes 5 out to here, but it might be 6, or it might be 7, or it might be 8. All right? Now, letter C, I had a little argument with my friend, and I found out that I was right. The power series converges at 2. I'm going to say might. And here's why. Have we ever seen an interval where on one side it was a bracket and on the other side it was a parentheses?
Yes.
Yes, we have. So even though I put a bracket here, theoretically it could be a parentheses. I don't know for sure. At 1.99999, it's going to converge, but 2, I'm not sure. So this is a might be true. Because it could be a bracket on one side and a parentheses on the other side. That's my symbology. What about D? The power series diverges if x is equal to -9. That's a might be true. Very good. And I'm not going to write down y because that was the same reason as A. Letter E. Does the series diverge if x equals -13? Definitely. Yes, it does. Because anything beyond 12 is a divergent. This must be true. It diverges when x is less than or equal to -12. Once I hit 6 on the right, it started diverging. And once it starts diverging, it can never reconverge. It can never reconverge. It only converges near where it touches, and then after that, it goes off into space. Okay? You're going to have a question like this on your homework, where you're going to have to build the number line also and then answer the questions. Okay? Any questions about these 5 problems? Yes? No? Okay. No? Are we good? Awesome. All right, turn the page, please. Now, we have a theorem at the top of the page. We are not going to add it to our flip book because it's not something that you're going to have to reproduce. But it is a theorem you need to be familiar with. Okay? So, I'm going to walk you through it for the interest of time. We have a function that is written out as a Taylor series. Okay? A sub n, x minus c to the n. It has a radius of convergence of r greater than 0. So it converges at more than just the point where the two graphs touch. Then on the interval of convergence, the function is differentiable. What does that mean? What does differentiable mean? You can take the derivative of it, and therefore it's also continuous. Moreover, so also the derivative and the antiderivative are as follows. Okay? So anytime you have a Taylor series, you can take its derivative and you can take its antiderivative. And that was part of the quiz you took today, yes? Where you had to take the, if you'd gotten all the way to part D, that was what you needed to do, was take the derivative of the P series, of the polynomial, in order to work it out. Okay? Now, take a look at this. Let me do this. Take a look at, here's my original equation. Now, if I wanted to take the derivative of this thing, a sub n is a constant. Constants just sit there. And then when you take the derivative of something with a power, the power comes down. And then the power drops by 1. So here is the derivative of that series. Okay? Then the next row gives you the antiderivative. Now, what does every indefinite integral have on its answer? Plus c. Notice where the c is. They put it in the front. Just because usually it goes constant, then the first x, and the next x, and the next x. So they put it in the front. And they wrote it in kind of a weird way. So we're going to write it the way we're used to seeing it. So this is going to be c plus sigma n equals 0 to infinity. A sub n just sits there. Then we put a parentheses. Then we put our x minus c. Usually it's just an x. What does the power do when you take an antiderivative? Does it go up or down? Goes up. So it was n, now it's what? N plus 1. So put an n plus 1 power up there. And then what goes in the front of it? 1 over n plus 1. So that answer and the one that I highlighted are the same thing. All right. Now, this may be a lot of going over your head a little bit, but that's okay. We're going to do this in practice. It'll make a lot more sense. But here's the key. The radius of convergence, helps if I use the right tool, the radius of convergence of the series obtained by differentiating or integrating the power series is the same as the original. So, what that means is, if I know that the regular series converges from -2 to 2, the derivative will also converge from -2 to 2. And the antiderivative will converge from -2 to 2. The only thing is, the interval of convergence, however, may differ as a result of the endpoints. So, you must check the endpoints on f prime and the integral of f of x. So if you ever take a derivative or an antiderivative of a series, you already know what the two numbers in the parentheses brackets are going to be, but you're going to have to check the endpoints. I didn't read that very carefully the first time I did it. And I went through all the thing of finding the interval of convergence for the derivative and went, oh, it's the same thing as the original. And then I read that and went, oh, I did all this work for nothing. So don't do the work for nothing. Don't be like Miss Bell. Okay? Now, let's do a problem where they use this. The example says the function f is defined by this. Does this function look familiar? If you were here yesterday, this should look like what we did yesterday. What was the fraction with the r's and the a's in it? What was that fraction? You remember? A over 1 minus r. Very good. So let's come over to the side like we did yesterday and write a over 1 minus r equals 1 over 1 minus x. Well, I had it right up there. Is it ready to tell me what a and r are going to be? Yes. What is a? 1. What is r? Just positive x. Agreed? Yes. So now you can write your series. N equals 0 to infinity. How does it go? We start with a, and then it's r to the n power. Done. Done. Write the Maclaurin series. Did it. Okay. Give the first 4 non-zero terms and the general term. So that means to start plugging in the ends. So 1x to the 0 over 0 factorial. 1x to the first. Wait, not over factorial. What am I doing? You just plug it in as you see it. 1x to the 0, 1x to the 1, 1x squared, 1x to the third, dot, dot, dot. 1x to the n. The nth term is what I wrote in the series, what I wrote inside the sigma. Okay, so step 1, done. Writing out the first 4 terms, done. Then it says, for what values of x does the series converge? Now we learned a shortcut for doing interval of convergence with these kinds of series. Does anybody remember what it is? Which thing? The A or the R?
R.
We take R, which is X, and it has to be less than 1, but one thing more. What did I forget? Absolute value. It's got to be an absolute value. Okay? So now, take the absolute values off by putting a -1 in the front. And remember that with these, the endpoints will never work. So you can go straight to the answer. Here is the interval of convergence. Done. Okay? Are we good so far? This isn't bad. All right. Use your answer to A to find the Maclaurin series for the derivative of f. Now, this thing I just built is f. Okay? I want to know what its derivative is. So the way we do this is we basically ignore the series thing at the beginning, and we just start taking the derivative of every single term. Okay? First of all, let's clean this up. What is this first term really? 1. And what's the derivative of 1? 0. I'm writing it down to show you term by term what's changing. So what's the derivative of the next term? X. What's the next derivative? 2x. No, wait. I don't think that second one is x. It's just 1. That's going to be a 1. This is going to be a 2x. What about the next one? 3x squared. Now, it says I need 4 non-zero terms. I got a 0. So I need to go 1 more. What's the next one going to be? 4x to the third plus dot, dot, dot. Now, if you just go to the end of the previous problem and take the derivative of that. So the n does what? Goes to the front, so it's n times x to the n minus 1. Done. That's the power rule, by the way. Okay. So, write the series out. Give the first 4 non-zero terms in the general term. So this happens to be n equals 0 to infinity. Throw that general term in there. Okay? Now, for what values of x does the series converge? Now, in the past, way back when, we had to do ratio tests to find out where it converged. But we don't do it now because we already know what the original equation did. The original equation was negative 1 to 1. So the interval of convergence is going to definitely be negative 1 to 1, but I can't put the parentheses on yet. I have to test the endpoints to see if they're going to converge or diverge. I know the negative 1 and 1 are right, but I don't know what the endpoints are going to do. Okay? So I'm going to write down test the endpoints. Very important that you do that. So let's do this. X equals negative 1. You have a couple of options when it comes to testing endpoints. You can plug it into the series notation, or you can just put in negative 1 for all the x's in the written out terms. And for some people, one is easier than the other. I'm going to go ahead and put it into the terms. Let's see what happens. We have 0 plus 1 minus 2. Now, if I put negative 1 into that 3x squared, is it going to be positive 3 or negative 3? I'm squaring negative 1, so it'll be positive. Times 3 is going to be positive 3. This is going to be an alternating series. Minus 4 plus dot, dot, dot. Okay. Converge or diverge? This is going to diverge. Let me show you why. If you add up every pair of terms, you're going to get negative 1. Do you see that? And if you add up all those negative 1s, you're just going to get negative infinity, basically. So this diverges. So that means negative 1 gets parentheses. Yes?
Like,
in order to converge.
yeah, so
They are, yes, you could do that too. You could do that too. She could, what she said was that's an alternating series, and the tests are the limit has to be going to 0. Well, it fails that test too. Is that limit going to 0? No. Those are getting bigger and bigger and bigger. So that's a diverger. That works too. Very good. Thank you for pointing that out. What about positive 1? If I go back over here and I put in 1 for all the x's, that would be 0 plus 1 plus 2 plus 3 plus 4 dot, 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 dot. What's that doing? That is diverging also. And there's really no test to call it. That's more of an obvious divergence. So that's a parentheses also. So in this one case, they did match, the function and its derivative. That doesn't always happen. All right. The last one kind of confused some people, so I'm going to try to make it as simple as I can. Use your answer to be to find the sum of this infinite series. This is kind of like what we did on the front. Kind of like it. But take a look at this compared to this. I'm going to highlight them both because they're both good and important. That is the same series. The question is, this one matches f prime. Kind of gave it away because it says use your answer to B. That's f prime. What is x? It's kind of hidden. Is x just 3? No, because it's on the bottom. Anybody got another guess as to what x could be if it's not 3?
Is it 1?
Say what you said again. It is 1 over 3. Because this function right here is the same thing as n times 1/3 to the n minus 1. Think about it. Because the top 1 to any power is just going to be a 1. And the 3 goes on the bottom. So, since this series matches f prime, instead of saying it matches e to the x or matches sine of x, we say it matches f prime. So the sum is going to be plugging a 1/3 in for x, right? So the sum is f prime of 3, of 1/3, excuse me. Let me fix that, I'm getting ahead of myself. Did I lose anybody? Okay. Do I need to say it again? Say yes or no? Yes. Yes. All right. I'm going to go back a page and show you something. Okay. Over here, when we found that something matched e to the x, for example, we found that they matched at that. We found the x where they matched, so we plugged in that 3 for that x, right? Over here, this matched sine. It matched sine where x is 2, so we wrote sine of 2. On this one, however, we don't have an equation. We just have the fact that this is f prime, because that's how we built it. At x equals 1/3, so the sum is f prime of 1/3. That's not really a number, okay? My question is, what does it equal? And we're going to find out right now. We know the equation for f of x. It told us at the top of the page. It is 1 over 1 minus x. Now take your brain, totally forget series, totally forget convergence for a minute. If I say this is f of x, what is f prime of 1/3? What do? Take the derivative of f, right? And then do what? Plug in a third. That's exactly what I'm going to do. So now I forget about all this upper stuff, and I just do that. So now take the derivative of this. I'd have to do Lodi high to that. Almost. You're very close. This is 1 minus x to the negative 1 power, right? So it's negative 1. Actually, you were right. 1 minus x to the what power? Negative 2 times the inner derivative. What's the inner derivative of this? Careful. Negative 1. So the negative times the negative is going to be a positive, so it's a positive 1 over 1 minus x squared. There's my derivative. Okay, so the sum is going to be taking that f prime equation, plugging in a third. So it's 1 over 1 minus a third squared. Scoot it up. What is 1 minus a third? 2/3. So this is 2/3 squared, which is 4 over 9. And flip it. There you go. Okay, I'm going to wait just a minute, let your brain process that. I'm going to talk through it one more time. Excuse me. So, it says using your answer to B, that was this function over here, find the sum. I looked at the two n terms and went, oh, they're the same. So this matches f prime and figured out what the x is. So that tells me to write f prime of a third. And then I came over here and did the math for that. Took the derivative, plugged in a third, I'm done. Questions? Turn the page. Now, that's the same equation from the previous page. So if you can open your paper up and you can copy this down, this is n equals 0 to infinity of 1 times x to the n, 1x to the 0, 1x to the 1, 1x squared, 1x to the third, and the interval, oops, I forgot my general term, plus dot 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 plus 1x to the n. The interval of convergence is -1 to 1. Okay, so I'll give you 2 seconds to write all that down. Please go back in the front of this and write down that this is f of x for me. Okay, that is f of x. Use your answer to A to find the Maclaurin series for that. Ooh. Integral with an x in it of f of t dt. Okay, give the first 4 non-zero terms in the general term. For what value does it converge? Now, this right here is f of x. How would I write it if I wanted f of t? Change all the x's to t's, right? So I want to find the integral from 0 to x of 1t to the 0 plus 1t to the first plus 1t squared plus 1t to the third plus dot 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 plus 1t to the n dt. So I changed my function f of x to t's. Does that make sense? Okay, because that's what I'm supposed to integrate. So, since all of these are just polynomials, I can just use the power rule on everything. Okay, this right here, remember, is just 1. What's the antiderivative of a 1? It's a t in this case, not an x. So this will be a t plus. Now come back to the second term. Let's move that up. What's the derivative? What's the antiderivative of this? 1/2 t squared, right? Plus, look at the next term. 1/3 t to the third. Plus, one more term. 1/4 t to the fourth plus dot dot dot. Plus, how do we write the antiderivative of this thing? N plus 1 t to the n plus 1. Okay. After we take an antiderivative, if we have limits of integration, remember we put the bracket on and do the 0 to the x. Right? This is a lot easier than it looks. First question, which one do I plug in first? The x or the 0? The x. So when I plug in x, what's going to happen? All my t's turn into x's. So let's write that down. So this will be x plus 1/2 x squared plus 1/3 x to the third plus 1/4 x to the fourth plus dot 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 plus 1 over n plus 1 x to the n plus 1. Yes, ma'am?
Do you have 1 taken off and just went straight to x's?
No. Now the only thing is we got to look at that 0. I'm supposed to plug in 0 for all of those t's. What's going to happen when I do? It's going to be straight 0 because everything is a variable. Are you with me? So I'm going to write in front of this the integral from 0 to 1 of f of t dt is that equation right there. And I'm going to mark out the 0 because I really don't need it. Okay. Now I'm going to go a step further, either on the front or back end, depending on where you have room. I want you to write the series. N equals 0 to infinity, 1 over n plus 1, x to the n plus 1. Okay, there's my series. Where does it converge? Negative 1 to 1 again. Whoops, got ahead of myself. I know it's negative 1 to 1, but I don't know what the endpoints do. Yes?
For the integral balance,
Oh, x, thank you. Now I know what you're talking about. Thank you. Appreciate that. Okay, I'm going to tell you right now that it's not going to be two parentheses in this case. All right? We're going to do this the short way. We're going to go straight to the series and see if we can see what's going on. Change all your x's to negative 1s. So that would be negative 1 plus 1/2. What's sign for the 1/3? It's negative 1/3 minus, no, plus 1/4, dot, dot, dot. Okay, what kind of series is that? That's alternating. The rules for alternating is the limit approaching 0. Yes. Are the terms getting smaller? Yes. So this converges by the alternating series test. Yes. Bracket goes on negative 1. X equals positive 1. Let's just write out the series. Well, that's going to just make them all positive, right? 1 plus 1/2 plus 1/3 plus 1/4, dot, dot, dot. How do you know it diverges? It's harmonic. It diverges. Exactly. Harmonic diverges. Parentheses. That's why we had to learn all that stuff. So there's my interval of convergence. Bracket, negative 1, comma, 1 parentheses. So for letter C, it says use the answer to B to find the sum of this series. Okay? So what I want to do is look at this compared to this. Are they kind of the same? Look at the two highlighted parts. Yes. I have the 1 over n plus 1. I have the 1 over n plus 1 right here. And then this is the 3 to the n plus 1 on the bottom. So what that is really 1 over n plus 1 times what to the n plus 1? It's a 1/3. So that means that x is 1/3. Are you with me? Okay. So now that I know what x is, I can go back and rewrite the function, putting in a 1/3 for the x. So the sum is going to be the integral from 0 to 1/3 of f of t dt, since x is 1/3. Okay? That function that I created with that series started as 0 to x f of t dt. It started up here. So I just figured out this thing matches this thing, except for x is 1/3. So I now go back and change this to have x as 1/3. Now I have just a regular old-fashioned integral. And I know the function of f of t from up here. All right? So this is going to be the integral of 0 to 1/3 of 1 over, what was it, 1 minus? Now it doesn't really matter if you write t's or x's. I'm going to write t's, because that's what it says. All right, guys, time to put your integral hats back on. How do you take the antiderivative of that? That is a negative ln, exactly. The bottom is almost the derivative of the top. It's just missing the negative. So this is the negative of the ln of absolute value of 1 minus t from 0 to 1/3. So this is negative ln absolute 1 minus a third minus negative ln absolute value of just 1. What is 1 minus a third? It's 2/3. Now I'm taking off the absolute value bars. Why? Because 2/3 is positive anyway. Yes, ma'am.
Why is ln negative?
Because when you check to see if you're going to use ln, you ask yourself, is the top the derivative of the bottom? And it is almost. The derivative of the bottom is a -1. So basically what I did is I put a negative here and a negative there. That's why. Okay? Plus, what's the ln of 1? That is 0. Okay? Now, I want to show you something. This is equal to that. Take a look at that. Take a look at what I just did. On a multiple choice, they might change it to this. Think about that one for a minute.
Oh, you flipped it.
Okay, how in the heck did I do that? Let's talk about that for a second, because this is kind of important. You might look at that and think, well, I didn't get the right answer. Yes, you did. Negative ln of 2/3 is the same thing as negative ln of 2 minus ln of 3, right? When you break it apart. Now distribute the negative. That would be negative ln of 2 plus ln of 3. Are you with me? Now switch them. ln of 3 minus ln of 2, which is the ln of 3/2. Interesting. Okay. Seems like kind of more work than it needs to be, but they do that sometimes. Yes, sir.
But you're like not really doing like when there's like a number for the ln, it's like a power what's inside.
Yes.
Just
That's another way to think of it. That's a very good way to think of it. You can also think of it as this. This is ln of 2/3 to the -1 power, because that's like a -1 in front of it. And when something's to the -1 power, what does it do? It flips it over. Okay? So that's a quick way to go to the answer. Very good. So that's another way to look at it. All right. Any questions on this lesson? All right, we are done with this.